Lesson 71 is all about parallelograms. Now, the first question we have says, in the parallelogram ABCD, the measure of angle A is 60 degrees. So if we look at this parallelogram, we know a parallelogram is just a quadrilateral that has two pairs of parallel sides. We've got A, B, C, and D. The measure of angle A is 60 degrees. So let's go ahead and fill that in. If the measure of angle A is 60 degrees, then the measure of angle C, directly across from it, must also be 60 degrees. We can see they're both acute, so they both must be the same in this parallelogram. Now, if we want to figure out what the measure of angle C is, we just did it because they're directly across from each other, and this is a parallelogram. So we've got our answer, 60 degrees. What is the measure of angle B? Now, angle B, we can see that this one is obtuse, but we don't know exactly what the measurement is. We're not going to use a protractor to measure this. We don't need to, because what we know that the interior angles of a quadrilateral will always add up to 360 degrees. So what we have is 360 degrees total for all four angles on the inside, minus, well, we have two 60s already, so we're going to take both of those away to figure out what both D and B will add up to. So if we double 60, we get 120. And when we subtract 120 from 360, we get 240. Now, 240 is what both D and B add up to. So half of 240, that's 120. Well, that must be each of these measurements. 120, 120 degrees. And when we add all these up, we get 360. So we know we've got the answer right. What is the measure of angle B? It must be 120 degrees. Let's move on to our next example. Now we need to find the area of the parallelogram. And the parallelogram here is the shape in orange. We've got the black dashed lines that are telling us how high this parallelogram is. Remember, height of a figure is always measured straight up and down. So if we want to find the area of this parallelogram, we can do that. If we were to take this whole shape and we were to push it back to the left on top, this would just be a rectangle. So if it were just a rectangle, if we push the shape back to the left on top, that means our formula is going to be the same to find the area of a parallelogram. Area is equal to the length times the width, L times W. When variables touch, it always means multiplication. So the length of the parallelogram, that's 6. The width of the parallelogram is also the height of the parallelogram. Now this one's tricky. It's tricky because the height is always straight up and down, and that's why we're given this information on the side. So the width of this is 5 centimeters. So we multiply 6 centimeters times 5 centimeters. That must give us 30 centimeters to the second power. We have 30 centimeters to the second power. That must be the area of our parallelogram. Lesson practice will be on page 383. Make sure you've got your notes complete, and I'll see you during our next class.